So this is Professor Gyanendra Tiwari once again from ABES Engineering College. So today I'm going to discuss one very interesting problem. Uh, it's actually on these two platforms. It's there on Hackerrank with the name as Ice Cream Parlor, and it's there on Leet Code as well with the name as Twosome. On Leet Code, the problem is a bit straightforward. On Hackerrank, they have made some story around the problem, some ice cream parlor story. That's fine, but the problem is same. Okay, so this is the disclaimer for this. Okay, let's try to understand what the problem is saying. So it's saying that Sunny and Johnny like to pool their money, and they want to go to some ice cream parlor, and Johnny never buys the same flavor that Sunny does, right? So of course, I mean, they want to test all the flavors. So of course, what Sunny will buy, Johnny will buy a different flavor so that they can combine and test both the flavors in the same money, right? The only other rule they have is that they spend all the money they have. That's what we do when we were kids, right? We don't save money for future. We spend whatever we have. So that's what Sunny and Johnny will also do. Okay. Now, given the list of prices for the flavors of ice cream, select the two that will cost all the money they have, right? So we will have a cost array or the price array, we can say. And from that array, we have to select any two flavors which we can buy in that money, and the total money has to be exhausted. Also, they are saying that the output has to be printed in ascending order of their indices, right? Okay, that's cool. Let's look at the constraints. The constraints are the number of test cases are from 1 to 50. So at max 50 test cases. The total money which Sunny and Johnny can have is from 2 to 10 to the power 4, right? A lot of money. And the total number of elements in this cost array would be from 2 to 10 to the power 4. So again, if you see the constraints, the total number of elements in the list or array is not much, right? It's 10 to the power 4 only. So we can, this simply says that we can go for n square solution as well, right? So we don't have to think much for the optimization, though we can do optimization, and we will cover that in the next video. But here we will see some really simple solution for this problem, which will pass all the test cases. Also in the constraint, they are also saying that the elements from this cost array will also range in the same range, that is 1 to 10 to the power 4, right? So let's see, the input format is very straightforward. It's saying the first line will contain the total number of test cases or the total number of trips they are making to the ice cream parlor as per the story. And for each test case, they have these three data. First line will contain the value of M, the total money they have pooled. Second line will contain N, that is the total number of elements in the array, or you can say total number of flavors of ice cream which we have. The cost array will contain N elements, and then in the last line we will have N space separated the value of this cost array, right? So that means the cost of all the ice creams. Okay, the index within the cost array represents the flavor of the ice cream also, you can say. Okay, so we have to print the indices. Indices represents what? The flavor of the ice cream. So if in the output they are saying print the flavors which they are purchasing, that means we have to print the indices of the array. The elements are elements of the array are basically the cost, and the indices of the array are representing what? The flavors, right? Okay, that's cool. So in the output format, it is saying for each test case, print the two space separated integers, which will be denoting the indices of the two flavors purchased, right? So what we can purchase in ascending order. So we have to print the indices in ascending order. And one more thing, when we'll go to the platform, you can see one more thing they have said that here the cost array, the indices which we have to print, the indices will be 1 based, not 0 based, right? So if you remember, in almost all the languages, the array or list whatever we have, it starts with index 0, but here we have to just print from 1 based indexing. That simply means that whatever indices we will get, the two indices, let's say I and J, we'll just add 1 to them, right? So it will make it 1 based indexing. That's it. So nothing else is required to change in the logic. That's it. So let's look at some example here. So they are saying that find first line is representing number of test cases or number of trips. So two trips, we have just taken the data for one trip. So in the first trip, the total money they have is 4 rupees. The total elements, or you can say the total flavors available are 5, and these are the costs, right? So what all ice creams they can purchase? So for 4 rupees, they can purchase, I think, 1 and 3 rupees ice cream, right? These two. And if you say one based indexing, this will be index number 1, this will be 2, 3, 4. So 1 space 4, that has to be the output. I hope it should be clear to you. Right, so now let's look at the approach how we do it. So remember I said we can also use a brute force approach for this, and it will pass all the test cases because the constraints are really small. So let's understand the approach what we are going to do in the code. So let's say these are the cost 2, 4, 5, 9, 6, anything 3, 1, something like this. And let's say the total money we have is how much? Okay, let's call it 13. So let's say we have 13 rupees in our pocket, right? So what approach we will be following is I'll be starting a loop of I from the end, and I'll be starting a loop of j from the beginning. Remember two pointer approach? Yes, we are going to use two pointer approach. Okay, so I will be moving in this direction, j will be moving in this direction, right? So what we will be doing, we'll be running j every time from 0 to I, wherever I is. And every time what we will do is we will add these two cost, ARR of I plus ARR of j. And if this addition, I mean the cost of these two flavors, is equals to the total money they have pooled, right? Then we are done, right? So in first iteration, what we'll do, we'll add this 1 with this 2. So 1 plus 2 is 3. Is it equal to the total money? No, 13, no. So j plus plus. Now 4 with 1, and similarly 5 with 1, 9 with 1. So all these we will test, and nobody will come out to be 13. So j loop will terminate, and when it will touch I, and then we will do I plus plus. I will reach here. Again, j will start comparing 3 plus 2, 4 plus 2, 9 plus, sorry, 3 plus 2, yes, 4 plus 3, right? 5 plus 3, 9 plus 3. So 9 plus 3 is okay, 12 only, right? We have to go to 13. So again, it will not do anything. So j will reach I and it will terminate. Then we will go to this. I will reach here again. J will test for all these 6 plus 2, 4 plus 6, 10. 5 plus 6 is how much? 11. 9 plus 6 is 15. So nothing is matching exactly 13. We have to exactly spend the entire money, right? Do you remember? Okay. So again, I minus minus, I will be moving backward. Again, J will be checking for all these options, right? So here, 13 will come as when we will check 4 plus 9, right? So 4 plus 9 will give me 13. So let's say this is our answer. Okay, 4 plus 9. So in output, since we have to print as one based indexing, let me check. Is there any other possibility before this? I mean, when I was at 1, there is nothing as 12. When I was at 3, there is nothing like 10. Okay. When I is at 6. So if we remember 7, there is nothing like 7. So no other possibility we have till now. Okay. So in output, we have to print, since this is at index 1, this is at index 2, index 3, index 4. So in output, we have to print 2 space 4, right? So that will be the output, 2 space 4. That will be the output for this particular test case. So I hope it is clear. Very simple loop, right? I will be moving in this direction, j will be moving in this direction, and that's it. Every time we will just add these two values, and whenever it will become equal to the total cost, we are done. We will break the loop, we'll come out of it, and we are done. Let's move at the platform and see how this code will look in action. Okay, so this is the problem on Hackerrank. Now let's look at the solution. So we'll select Python 3, and this is the function which we have to complete. Let's first of all give some useful or meaningful name. So this ARR, that is the cost array, let's give it a name as cost. And this M, that is the total money they have, let's call it T or small t M, total money, right? Okay. Make sense now? Okay. Now, what first of all, what we have to do? We have to store the length of this array, cost array. So we'll say length of this cost array. Okay, we'll be storing it in n. Then what we have to do? Let's make a result list for storing the result. Okay, and I think we are good to go. Let's start a for loop for I in range. So we have to start I from n minus 1, right? So for I in range n minus 1 to 0 and every time minus 1, right? And what we have to do every time? We have to check if this element of I, that is the cost, if the cost of this particular ice cream is less than the total money we have, right? If this is the case, so we'll say if this is the case, then what we will do? Then we will check for the J for it. Are you getting what I'm doing? We are just checking that, let's say the cost of this single ice cream, we are pointing with I. If the single cost is greater than the total money we have, there is no point of choosing another ice cream which can make a combination with it, right? Because already this cost is greater than the total money we have. So there's no point of checking any another test, another flavor for this particular ice cream. So we will be removing it. So it's a small optimization, you can say. Now, if that cost is less than the total money we have, then it could be one of the solution. So for all those cases, what we will do is we will run a loop of J. So we'll say for J in range of I. So J will be running from 0 till I minus 1, of course. So J will run from 0 till I minus 1. And every time what we will do is we will see that the total cost, let's say call it TC, the total cost, how we will calculate the total cost? The cost of ice cream I plus the cost of ice cream J. If these two costs, that is the total cost, if this total cost is equals to the total money we have, right? Then we are done, right? Then we are done. So we will store it in the result. We'll store this value in the result. And remember, which will be smaller, J or I? J, right? Because J is coming from this side. I is already coming from end. So we have to print the smaller one first and larger one at the later on, right? In ascending order in the output. So we'll be doing J plus 1, comma, I plus 1, right? Why plus 1? Because we have to do it 1 based indexing, right? So normally the indices will be 0 based. So we'll just add 1 to it. It will become 1 based indexing. Okay. So result is done. Now we don't have to move ahead. We can break from this loop and we just have to return the result. So return the result, and that's it, I think. Let's run it and check it if it is passing. Okay.